Min Zhang is a principal scientist and group leader at Fujifilm Diosynth. He is going to be presenting the Media Toolbox, a rapid and effective process development strategy to deliver reliable, high-quality biomanufacturing processes. So with that, let me introduce Min.
Thank you very much, Brian, for the nice introduction. And I would like to continue the story from a cell line you guys just heard, from Lanza to the media and feed development as well as the process development. Because we all know bioprocess development is a very fun area and they need a lot of attention. So I would like to take this opportunity to introduce a rapid and effective process development strategy at the Fujifilm we call Media Toolbox to help deliver the reliable, high quality and biomanufacturing processes. Here's the outline of my presentation. First, I'll briefly talk about the background about Fujifilm Diosynth and the tool development innovation activities. These days, we'll talk quite a lot about innovation, so I would like to introduce you about the activity in Fujifilm. Then I'll get to the topic why and we want to do the Media Toolbox, followed by a couple of case studies to highlight the advantages of Media Toolbox. Then finally, I'll conclude my presentation with the tool development strategy at Fujifilm. So a little bit of background about the Fujifilm Diosynth biotechnologies. You can see here we have three different sites, two sites at US, one site at Birmingham, UK. At Research Triangle Park, North Carolina, and Birmingham, UK, we have capability to the biologic process development as well as manufacturing. And we also have the College Station at Texas, US, has the capability about viral vaccine and gene therapy process development as well as manufacturing. So total we have about 1,100 staff scientists and people. So far we have developed over 230 development products as well as processes, including 5 commercial products, 4 fermentation microbial products, and 1 cell culture product. So with consideration of the continuous improvement of efficiency and efficacy, so 2 major drivers at the Fujifilm, which include the innovation as a focus as well as the implementation of the Lean Six Sigma products. So we continue to improve, these areas. And historically, we have pretty extensive successful inspection history from the major regulatory agencies. Okay. Well, this slide shows the GMP manufacturing capability, including microbial, fermentation, as well as mammalian cell culture. So on the left, it shows the fermentation area. So you can say, in non-GMP PD facility, we have 100-liter or 200-liter fermenters, okay, at 3 different sites. In the GMP area, we have, the scale from 100-liter, 200-liter, and all the way to 5,000-liter fermenters, including 3 by 2,000-liter stainless steel fermenters in RTP and 2 by 5,000-liter fermenters in Birmingham, UK. On the right side, you can see the mammalian cell culture capability. Similar as fermentation, we have, in R&D or PD, we have 10-liter and 200-liter single-use bioreactors. Okay. In the GMP area, we have 200-liter, 500, all the way to 1,000 and 2,000-liter single-use bioreactors, 3 different sites. To give us more flexibility, depending on the client's needs, we also have 1 production train in the stainless steel reactor as well, including 1 650-liter stainless steel reactor and 2,000-liter stainless steel reactors. All right, as I mentioned earlier on, innovation is always our goal. So Fujifilm is committed to the continuous innovation of technologies, service delivery, and quality for our clients. So I start, from the bottom. You can say, we have established a very well single-use process platform for mammalian cell culture. And also, to make the process more efficient, we have the streamlined approach to analytical and process development. And our analytical head, Greg Adam, will present the analytical capability tomorrow, so please welcome by joining us tomorrow. He will give a talk in the morning. And just last year, Fujifilm launched Apollo Chill Expression System with a collaboration between UK and RTP side. So for this platform, we have our own proprietary host cell line, expression vector, cell line process development, as well as a platform media and feed. So which is, we're pretty excited about that. I will show some data later on about that. So for this presentation, I really want to focus on the media toolbox, which are highlighted here, the chill basal media and the feed media. Okay. So let's get to the topic. Why we want to do Media Toolbox? Okay. So during the journey of process development, from gene and all the way to manufacturing, including cell line development, process development, and manufacturing, regardless of the development stage as well as the clinical stage, it's always a desire to have the shorter timeline, high performance as well as reliable process, which are reflected by the speed, quality, and robustness. So before I get to the improvement, I would like to introduce a little bit of background of the Fujifilm. That's what we observed a few years ago. So we have pretty good, platform before, and we achieved the titer of the antibodies about 0.5 gram to 2.5 grams per liter. The titer was low at this point, but at that time it's not too bad. However, we have some limitation on the media and the feed because we don't have much information about the media and the feed, so we had to rely on vendors and the information from client. I would think this is not only to Fujifilm, but also to quite a lot of other companies, unless you are the media vendor. Okay. So after a few years innovation activities, we got a significant improvement on this. So right now, we achieved the monoclonal antibody titer over 5 grams per liter with 2 different routes, including the platform, media, and the feed to support Apollo Chill expression system, as I mentioned early on. And the target for this presentation is a medium feed toolbox. We also achieved a similar titer range with acceptable product quality to cover the different cell line diversity. So please keep in mind the good cell line diversity is a key for the whole presentation. I would like to talk about more about this. Okay. So before we answer why we wanted a media toolbox, you may have a question: what is a media toolbox? So basically, the Media Toolbox is a collection of high-performing basal media and feed media used for screening diverse chill cell lines to rapidly deliver high performance. And media are available for GMP use from several top media vendors. Okay. So at the bottom, you can say this is the approach we developed and established the Media Toolbox. So with a good cell line diversity as a focus, Fujifilm has screened quite a lot of off-shelf products as well as prototype basal media and feed media from a lot of diverse, from different vendors to cover a lot of diverse chill cell lines. So you can see the number here, including 63 basal media, 19 feed from 6 different major vendors, as well as 15 different chill cell lines, and cover all the cell subtypes in this market, DG44, GS chill, DuxB11, you name it, so pretty much everything, to cover the good cell line diversity. So the first advantage to answer the question why we want to do Media Toolbox is the speed. We all know, the timeline is important to our client. We want to help them to make the process as fast as we can. So in the current toolbox, the idea is we want to limit the number of the media and the feed to around 4 to 5 in that regard. So you can avoid random testing of many media products from different vendors with great time and cost saving. So almost every year, or maybe 2 or 3 years, media vendor they launch the new products. But to the efficiency wise, you may not want to test all of them. That's why we want to do this. Based on experience at Fujifilm, we have achieved pretty good success story behind this, and we feel good about the high probability of success about it. So here is just quickly show the timeline. How do we do the toolbox? Upon receiving the client cell line in the original media, it takes about 3 weeks to adapt the chill cells from original media into new media to make sure the performance is representative in new media. After that, we would like to perform a media feed screening in the shake flask to identify the top 3 to 4 media feed combinations by considering the cell growth, metabolism, titers, and the product quality. Product quality is very important. So we want to make sure the product quality attributes to the top conditions are acceptable. Okay. So the top 4 conditions then will be confirmed in the benchtop bioreactors, which takes another 4 weeks. And finally, by considering a similar strategy, we look at the cell growth, metabolism, titer, and the product quality for all the conditions, identify the top 1 condition to move forward, followed by further process optimization work. So you can see from here, it takes about 3 months or even less to identify the better process after implementation of the toolbox. That's a really key we want to let you guys know about it. So the second advantage is efficacy. I would like to use a couple of case studies to show how efficient and effective of the toolbox. The first case study is the GS chill and is also expressing the monoclonal antibody. So we improved the titer from 1 gram per liter to over 5 grams per liter in 3 months, basically. A little bit of background about this case study. This GS2 map process, using a pretty complicated media, as was the feed process, was transferred to Fujifilm PD lab about 7 or 8 years ago for phase 1 and 2 process transfer. And this process was scaled up to 2,000 liter stainless steel bioreactors for 10 successful GMP batches to achieve a titer around 2.5 grams per liter about 80 years ago. However, upon returning to phase 3 manufacturing, first we introduced the process back to the PD lab again. We got some big challenge. We cannot reproduce the same process as we did 7 years ago. So after the decent investigation of the root cause, even we don't know exact reason for that, but all the evidence suggests the raw material and the complex media variation could be the driver for this, could be the reason for that, including hydrolysis. I believe all you know, hydrolysis is not desirable in the mammalian cell culture. So, to fit the project timeline as well as a clinical timeline, we convinced the sponsor, which is the client, to test our toolbox. I forgot to mention our toolbox is completely defined media and feed. Okay, that's a benefit. We fully understand at that moment it's a big decision for our client to change the process because it's close to phase 3. It's not desirable to change the process at this moment. So especially for the product quality, we want to make sure the product quality can drop into acceptable range, which is very critical. Here to show some benefit of the implementation of the toolbox. Keep in mind, original process had hydrolysis inlet, and the feed strategy is very complicated. The whole process contains 5 bolus feed, very, very complicated. So it's really not friendly to manufacturing. Okay, so you can see on the left, to show the cell growth chart. It's a little bit busy chart. And at the bottom, to show the viable cell density. The top to show the cell viability. To the very bottom, so you can see the cell growth in 2007, that's in 110 liter stainless steel. We achieve a peak viable cell density about 7 to 8 million cells per mil. And once we repeat the same process last year in 200 liter single-use bioreactor, actually the cell growth looks very similar. We're pretty happy at that moment before we saw the titer data. After implementing the toolbox, so you can say there's a significant increase of cell growth. It's over 10 million cells per mil. Not only to the cell number, but also to the viability. We pretty much prolong the duration of the cell growth. Okay. So you can say, that's a big challenge after we saw the titer. Even the cell growth look very similar between, the 2 different time frames. However, the titer, once we repeat the same process last year, is only a little bit over 1 gram per liter. It's about half as compared to historical data. So it really raised a big concern at that time because the client timeline is really approaching at that moment. Very difficult. After we implement the toolbox, that's a big jump we can see here. Okay, so same cell line, the only change is the medium, feed, and the process. And you can see the data here. So I'm showing the data from the reactor at different scales, including 2 liter, which is in the red. The 10 liter is a blue, is a purple, and the green is a 200 liter. So basically, all the titer look very similar across the different scales, which suggests very good scalability and reproducibility. Okay, so we achieved the titer of 5 grams per liter, and also almost double the original process titer compared to 7 years ago. And another benefit of the toolbox is, as I mentioned earlier on, our toolbox is completely chemically defined. Okay, so in that regard, we can avoid the same issue happening again in the future if this project goes to the commercial production. Okay, so as we all know, the simpler the better, because the feed strategy also being simplified by using toolbox. So the next question we want to answer is the product quality, which is more important than the titer. So you can see here, as compared to the reference material, which was a material generated 7 years ago. Once we repeat the same process in the PD lab, here is show the glycan data. And the data from 200 liter highlighted by I believe that's orange or yellow here. So you can say that's quite different from the original material. So this concern even worse than the titer at that moment. That's the last summer. I still remember that tough time at that moment. However, once we implement the Media Toolbox, you can see the improvement here. The green bars show the glycan data for the new process. If you compare all the different glycan isoforms, they're almost right on as compared to, almost identical as a material from the old process. So this is only to show the glycan data. We also have similar data to other product quality attributes we examined before, including charity variants, aggregates, as well as the half antibodies. Okay, so our client is extremely happy about it. Actually, before I came here, and we plan to start a 2,000 liter GMP run this week. So Viathon started this Thursday. Real time, ongoing right now. This is the first case study. The second one, I want to show another story from the CHO DuxB11. This is mainly the one that I let you guys know in a good cell line diversity coverage by the toolbox. Okay. Quite different from the first case study, because the first one was a phase 3 process change. For this one, is an early phase project with clone selection involvement. And basically, we were requested by the client to identify the development process for the phase 1 GMP manufacturing. So we received 3 different clones, DuxB11. However, there are also some big challenge at the beginning. The titer, is pretty low once we receive the clones. It's only around 200 to 300 mg per liter. So based on the clinical needs by the client, they want us to improve the titer over 600 mg per liter, so almost double, the titer. Okay, so it's difficult, but we try the toolbox. So you can see the improvement here. Okay, with all 3 different cell lines, the IgG titer was improved almost 5-fold. Okay, so the highest titer we achieve about 1.6 grams per liter. And we also examined the product quality attributes as well, including glycans, charity variants, aggregates. So pretty much, all the key product quality attributes, they are well within the acceptable range. So our client is really happy because it's much more than expected. Even they joke about it because it's close to Christmas, they want to send us Christmas gift for that. Okay. So one of the conditions was selected from the PD lab and moved into the manufacturing. Here's the data, across the different scales. Similar to the first case, the big chart shows the cell growth. The variability shows on the top, the variable cell density shows at the bottom, and the inside small picture shows the titer. You can see at the different scales, including 2 liter, that's a bench scale bioreactor, 10 liter single-use bioreactor, and 200 liter in PD, as well as 1,000 liter GMP run in our manufacturing area. So all the cell growth and the titer almost right on, which suggests the very good process scalability and reproducibility. You can see this robustness of the process by using the toolbox. Okay, so all this will well demonstrate at PD and the manufacturing. We're very happy about that. So this is the second case to outline efficacy of the Media Toolbox, and I believe now we already answered our question why we want to do the Media Toolbox and why we want to convince our client to use the toolbox because we know it works. So to end on my presentation, I would like to outline 3 development scenarios at the Fujifilm. So if a client has a good process and the timeline is critical for them, they can just directly transfer the process to us. You can see at the bottom. So basically, at the PD lab, we'll do 1 to 2 transfer run and scale up to 200 liter diamond batch before we transfer GMP manufacturing. So if a client wants to start from the very beginning, from gene to manufacturing, we can use Apollo 2 platform. So you can see at the top. So our UK facility have a cell line development capability, and also after clone selection, we'll perform the Amber 15, increased throughput. These days, Amber is really popular. So at the UK, we have 2 Amber 15, which has 48 small mini reactors capability, and also we have Amber 250 as well, can be used in both cell culture and fermentation. Okay. And after identify a few clones and a regional process, this process will be optimized in 1 or 2 sets of benchtop bioreactors before we scale up to 200 liter diamond batch, then transfer the GMP manufacturing. Okay. The highlight for this presentation, which is toolbox, as I mentioned earlier. Okay. So if a client has their own cell line, want to improve in a quick manner, we can do that. It takes about 3 months to identify the top condition and confirm and optimize in the benchtop reactors, 1 or 2 sets of DOE studies. Then we'll move on to the 200 liter diamond batch. The material from diamond batch can be used for the toxicology study for the early phase, or just demonstrate everything before we scale up to the GMP scale. either 1,000 liter or 2,000 liter bioreactors. Okay, so it's really depending on what the client's needs. We have the different diversity and flexibility to cover this. Okay, so this really the teamwork. I would like to thank a lot of people involved in this, because these days we'll talk quite a lot about innovation. That's an innovation we are doing, and we'll continue to do that. So including the PD from upstream, analytical, marketing, sales, and the senior management support is critical for the success of the whole development work. Okay. So I'll stop here, and if you have more questions, want to get more details, please feel free to visit us at booth 3317, which is right behind me, to support me of this talk. So, and also I'll be happy to answer any questions. Like what I said, if you have a question, you can feel free to stop by the booth. We'll answer questions. Sorry, I cannot hear it from here.
Can you hear me now?
It's not working, I guess. It's on? Okay.
So how long will a toolbox experiment take to complete from beginning to end, just from the transfer part?
If I hear you correctly, so how long of the toolbox can develop final process to manufacturing? Okay. So as I mentioned early on, it takes about 3 months to identify the top condition in the PD lab. Then it takes a 1 to 2 set of DOE started in the bench reactors, which take about 1 to 2 months. Then scale up to 200 liter tox batch takes another month. So I would say it takes less than 6 months, probably around 5 months, we can move to the manufacturing. And the manufacturing takes about 1 to 2 months to complete. So essentially it takes about a little bit of half year to generate material for the clinical needs by the client.